From above, the Siberian expanse looks like a monument to absolute stillness. Thousands of miles of frozen forests and ice create a landscape where time itself seems to have completely stopped. This massive stretch of Earth is part of Eurasia, long considered one of the thickest, most impenetrable tectonic blocks on the planet. But look closely at the map, and a sharp anomaly interrupts that solid ground. A long, thin, 636-kilometer scar cuts directly through the terrain. This cross-section shows exactly how abnormal this feature is. While a standard lake sits in a shallow, bowl-like depression, Lake Baikal plunges to a staggering 10,642 meters. The bottom of this trench sits far below sea level. Most lakes eventually settle into a stable shape. Their shorelines lock into place. Here, the edges of the water are physically shifting. This satellite map highlights the movement of the ground beneath the water. The rock itself is stretching, slowly pulling away from the center of the lake in opposite directions. Baikal represents an active, continent-cracking tear. It leaves geologists with a difficult question. What invisible power could possibly split the seemingly indestructible Eurasian plate? To find the source of that pressure, we have to look thousands of miles to the south and rewind millions of years to the exact moment the Indian plate violently slammed into Eurasia. The immediate consequence of that massive impact is visible here. The Earth's crust buckled upward under extreme compression, building the towering peaks of the Himalayas. But the kinetic energy from that crash didn't stop at the mountains. As this map outlines, immense pressure waves propagated outward, driving deep into the Asian continent. That tectonic stress traveled continuously northward until it hit a pre-existing structural weakness buried beneath Siberian ice. Instead of folding upward to make new mountains, the immense tension forced the deep, solid bedrock of Siberia to groan, fracture, and pull apart laterally. Geologists call this a continental rift zone. As the massive plates pull apart, the unsupported ground in the middle slowly collapses downward, creating a steep, narrow basin that fills with water. The impossible depth of Baikal is actually a sunken structural failure. It is a delayed, distant echo of a Seismographs record between 3,000 and 8,000 microearthquakes in the Baikal region every single year as the subterranean rocks grind and slip. Sometimes those shifts are sudden and catastrophic. During a 19th century earthquake, a massive section of farmland completely dropped away, immediately flooding to form what is now known as Proval Bay. The crust here has stretched so thin that heat from the mantle easily reaches the surface. Even surrounded by deep winter snow, locals bathe in natural hot springs that can reach temperatures up to 80 degrees Celsius. At the lake bed's bottom, that heat drives streams of methane gas and thermal water bubbling directly out of jagged cracks in the rock. GPS data confirmed exactly what was happening. This schematic shows the lake's borders actively migrating, pushing away from each other at 2 to 20 millimeters every year. Beneath the waterline, drill cores reveal kilometers of dense sediment stacked in the trench. Debris has piled up for eons, proving the central floor is steadily dropping to accommodate the gap. Thousands of earthquakes, intense geothermal heat, constantly escaping gases, and real-time GPS spread rates all point to one physical reality. Baikal is a living fault line, actively tearing a continent in two. To understand where this ends, we don't have to guess. Earth has run this exact sequence of continental tearing many times before. Millions of years ago, the space between Africa and the Arabian Peninsula was a landlocked continental rift, lined with lakes remarkably similar to Baikal. Eventually, the gap stretched wide enough that ocean water breached the walls, creating the Red Sea. We can observe a similar early-stage split today in the East African Rift, where vast stretches of terraced land are visibly cracking apart. When geologists apply predictive computer models to the current spreading rate in Siberia, the future map of Asia radically changes. Over the next 20 to 50 million years, this hyperlapsed model shows the Baikal scar tearing dramatically wider. The ground drops entirely, allowing global seawater to rush in from the northern edge of the continent. The landmass is cleanly severed. Human lifespans are too brief to witness the violence of these planetary shifts. But beneath its serene, frozen surface, Lake Baikal is quietly incubating Earth's next vast ocean.